By the end of this video, you will understand how Jupiter's auroras act like massive chemical factories, and what that tells us about magnetic fields. First, let's look at the location. This is Jupiter's south pole, a region we couldn't see clearly until the Juno spacecraft arrived. The crucial concept here is solar chemistry. Normally, the sun's rays build chemicals like acetylene at the equator, so there should be less of it at the dark poles. Now, here is the surprise. Using ultraviolet sensors, scientists found a massive concentration of acetylene right inside Jupiter's southern auroral oval. Let's distinguish this. The sun isn't making these chemicals. The auroras are. Jupiter's intense magnetic field funnels charged particles from space into the atmosphere like a high-speed collision course. When these high-energy particles smash into the atmospheric gases, their energy forces atoms to recombine into new molecules. Scientists proved this by looking at ultraviolet shadows. The acetylene absorbs specific UV light, leaving a dark footprint exactly where the aurora shines. Why does this matter? It shows us that magnetic fields and space weather don't just create light shows. They fundamentally alter a planet's atmosphere. You now understand how auroras manufacture chemicals. This knowledge helps you appreciate the invisible forces shaping the atmospheres of giant planets.